Hi friends, and welcome to Comprehensive Tutorials. In today's video we will be looking at what we call class templates. So we have done function templates in a previous video and we will be building over that concept. Now before we start the agenda for today, let's quickly look at our setup for those of our friends who will be joining us for the first time. So we have the include IO stream over here, which I assume you know already, and this line over here is specific to this environment code blocks. Specifically my environment, you might be using code blocks, but you don't need to include this line. So that's just for this environment. Now we have the using namespace std as usual, and these two lines define nl and t as constants so that we can replace them. We can use them in place of nl. We can use them in place of endl, and then the escape sequence t to denote a tab. Then we have our void class templates function over here. Now you guys, most of you will be running your code, whatever that I will be writing over here. So anything I write in the class templates function, you will be writing it in your int main function. So because of my setup, I will be writing my code over here, but you'll be writing yours in int main. And then any code I will be writing outside of the void classes templates, then you will be writing it outside of your int main function. So basically void class template is my int main function. Okay, everything is going to be perfect. You just write it in here, whatever I write in there. Right, so let's get to it. So we want to talk about class templates, but before then let's quickly recap a quick one over the function templates that we did the other time, and then we build from there. So these are just comments that will guide me through this tutorial. Right, so first I want to create a function template, and this example is taken from the C++ website. Great. So to create a function template, you come outside of your int main function, and then you use the template keyword, and then you have parentheses, and you have class T. I want to believe you know how to create templates already. The T is the variable that will be replaced, so you can have integers, float. We'll look at that in a bit. Then after that, you want to have your function return a T. So if you pass in an integer, you want it to return a T, an integer. And the name of the function is going to be sum, and this is going to take an object from the class T. So we would have T, let's say T of A, you can name it B or anything that you want. Then we would have T of B again. So we'll be taking two objects because we want to add them. Great. Now the next thing to do is to have the curly brackets where we'll be writing our functionality. So we want to get in here, and then we say that we want to declare a variable of the class T to be called, we can just say it's result, and then we want to store whatever thing that would compute inside that result. So we want to say that A plus B should be stored in result, then want to return result. Great. So we have our template for we have our function template. So this is a template for a function called sum. So then we can get in here, and then we call sum, and we have to pass in the template that we will be working with. So we pass in an int over here, and then we have our parentheses where we pass in the values that we want to add. So 3 and 6 are integers, and then when we run this, we don't have any compile time error, so it means you are good to go. So to output this, let's see out whatever value that was computed. So we have 9, so 3 plus 6 is 9. Great. If we pass in a double over here, let's say 6.7, we run this, we have 9, because this will be converted to an integer. The 6.6, the 6.7 will be converted to an integer 6. So that's why. But then we don't need that to happen. So in order to override this, we have to tell the computer that whatever we are passing is a float, or whatever we are passing is a double. We go ahead and run this. So then we have 9.7 over there. So we can also have strings as well. So let's go ahead and put a string over here so we can add strings. So the first one, want to pass a string. Let's say this is hello, my usual hello, and I've put a space there so that it would be spaced between the world and the hello. So hello world. Let's run this. And now we have hello world over there as such. So what this structure, what the advantage it provides us is that we don't have to write a sum function for int separately, a sum function for float separately, a sum function for string separately. It provides us the structure on which to build on readily. So that's what templates or functional templates are. Now we can also have the class. So we worked on the class integers, float, strings. What if we want to work on our class vectors? How do we do that? So in the previous video we had class vectors. So let's quickly create our class vector so we can create objects of it, and then we can see whether we can add them using this template over here. So to do that, let's quickly create our class. So we would have our class called vector. This is going to be called a vector. We'll open it and it will have public attributes. And we want to say that it's going to have x and y components. So we would say float x and float y. Then after that, we want to have a constructor to allow us to pass these attributes during the point of construction. And the constructor is to have the name of the class. And this is going to accept, let's say, float a and the float b. Then after that, we are using the member or initialization format. So after that, we want to set the x component to be the a that will be accepted, and we want to set the y component to be the b that will be accepted. Then after that, we'll have our parentheses, our curl brackets, and then a semicolon, right? Then after that, so this will allow us to create our object. So then we come down here and then we create one of our objects. Let's say vector1, and we are calling that 2 3. We're putting 2 3 in there. So when this 2 3 is taken, it will be assigned to x and y. So let's go ahead, comment this out, and work with this for some time. So when we have vector1 dot x, it will be cout. So let's just go ahead and cout that to see if it's working. Right, so we have 2 over there. Great, so it's working perfectly. Now the next thing we want to do is to, let's just say that we want to print these components. So we want to have a method called void print, because it's not going to return anything. It's just going to output something. We will not be taking anything. We'll just be seeing out the components. So we'd see out parentheses with x, and then we would have a comma. Then after that we would have y, and after that we would close it with a parenthesis, and then we'll close it with a new line as such. Right, so let's go ahead and call, we don't need a cout here because there is a cout over here already, so we just need to say vector1.print. So this is just a quick recap. I want to build on whatever we have done. We run this and we should be getting the components 2 3 in a mathematical format. So we have it there as such. Now the next thing we want to do is to create 2 objects. So we have vector vec2, and then we want to put in a 4 and a 5 over there. So then we have our 2 objects ready, right? Great. So can we then apply it to this particular structure over here? So we have our sum, which is going to be taking objects from the class vector. And then the first object is going to be, let's say, vect1. The second object is going to be vect2. Can we do this? So when we pass in these vect1 and vect2, they would be put over here. So it's going to be vector sum is going to be vect1, vect2. Then it will get in and create a variable called result, vector result, and it's going to be stored. This is going to be whatever is going to happen. Okay, so let me just run this and then see if that's possible. So we run this, and now we have no match for operator plus, right? So then this operator plus is defined for integers, it's defined for floats, it's defined for strings, but it's not defined for vectors. So what we have to do is to overload that operator. We have done overloading operator. We'll just be quickly running over it. So to overload that operator, we would have the vector keyword, and then not a keyword is the name of a class. Operator is a keyword plus the operator we are overloading, and what are we going to be accepting? So we're going to be doing the non-member format. So we will be accepting, let's say, constant. You can just pass them there directly, but it's good practice to pass them by referencing. So constant vector A, we have done that in the previous video, so we'll just be going over it quickly. We want to have constant vector B, and then what we want to do is to get in here and create an empty vector object, right? And then we want to assign the answer dot the x component to be a dot the x component plus b dot x component, and then we want to assign answer dot y to be a dot y then plus b dot y as such, and all we want to do is to return answer. Great, so we are done overloading our operator. But before we can write this, before we can have an empty vector object, we have to have a constructor that allows us to create that. Okay, so we have vector, and this is just going to be an empty object, so we don't have any error. Right, so then we have our operator. So we have defined what this operator over here should be doing for the class vector. So anytime a vector object is passed, what this operator should mean to that class vector is now defined. So now we have our two objects, vector1, vector2, and we are calling the sum and we are adding them. Let's see if this will make sense to the computer. Great, it's made sense to it. We've had no compile time error. Now the result that was returned was of the class vector. So to get the components, let's just put this in parentheses so that it will be one full object dot, then we can say dot print, so that it will give us the components of that particular result. So we run this and now we have 6, 8 over here. So let's see if that's right. 2 plus 4 is 6, 3 plus 5 is 8. Great. So that was function templating. Now we'll quickly go over class templating. So to do that, we'll create a class called pair of objects. So there are two objects from the class, right? So what we want to do to illustrate this is that we want to create a class. First of all, we want to create a class, not a template. We would link it up to the concept of class templating later. But we just want to create a class to allow us to take two objects from a same class. So we can group integers, we can group floats, we can group vectors, right? Great. So let's go ahead and then do this. So we have class, we want to name it pair of objects, and then after that we would have our parentheses, our curly brackets. So this is going to take, let's say, the first object, object1. Let's just call it object1, and then the second one is going to be, so any object of this class called pair of objects is to have two objects, object1 and object2, right? So object2. Then I think we should make these public. You might have noticed that I have not put in the type of these particular objects, and that's for a reason. Great. So then we would have a constructor, and the constructor would have the same name as the class, so that we can create, or we can pass these objects at the point of creation. So we would have, let's say, A and then B, right? Then after that, we are using the member initialization again. Then after that, we want to assign object 1 to be the value A that will be passed, and then object 2 to be B. Then after that, we want to have our curly brackets, of course. So this is a constructor to allow us to create that object. Now let's say that we want to pair objects which are of the type integers. In that case, the first object is going to be an integer, and the second object is going to be an integer. And then when we are passing these objects at the point of creation, we want the first one to be an integer, of course, and the second one to be an integer. Then when those are taken, then object 1 is assigned A, object 2 is assigned B. Now what we have to do is to construct, so let's just clear this. All we have to do is to construct an object from the class pair of objects. To do that, we'll just use the name of the class pair of objects, and then we want to call this pair1, and we want to just put in 2 and 3 over there, right? Okay, let's just say 2 and 4. Great. So we run this and hopefully we should not be getting any error, right? We are past compile time, so meaning there is no error. Now we can output pair1 dot object 1 and it's going to return 2. We can output pair1 dot object 2 and it's going to return 4. But that's not what we want to be looking at here. We want to pair them. So to pair them, I think we've been able to pair them already. But then okay, now we have paired integers. Let's say if we can pair float. To be able to do that, we have to use the float keyword over here, and then we have to change all the integers to floats. Then if we want to do that for strings, we have to go around changing the int to string. But there's an easier way of doing this. That's using the class templating. So this is a class to do something, and that thing is going to be done repeatedly. So it's better we create a template for that repeated action. Over here, our function was going to be doing something repeatedly for different data types. So that's why we needed a template for that function. So here, our class is going to be doing repeated action. So we need that repeated action to be done easily. So that's why we need a template. So we'll have template over here, the template keyword, note that, and we will be passing in the class that will be accepted. So we have class, let's just say class T, right? Then when we pass a class T over here, so let's say we pass integer over here, then after that we want this place to be replaced by whatever value that was passed. So int object, and then int object 2, and we want to be accepting objects of class T, and then want to accept class T. So if we then replace T with float, it works for float. If we replace T with strings, it works for strings, and all of that functionality. So let's go ahead and see how we can access these. Now to do this, we would need the arrow operators over here. So we have these operators over here. Because this is a template, this class pair of objects is now a template, so we have to specify the class that it will be accepting over here. So let's say that this is accepting an int, right? This is accepting an int, and then we call this pair int, and then we are printing these ones. Sorry, not printing, inputting these ones. Let's run this to see if we have any error. Right, no compile time error. So then how do we view them? We can say pair1 dot object 1 and it will print 2 and all of that, but let's just go ahead and write a method for that. So let's say that our method is going to be called void print again, and this is going to just see out. Okay, so let's say object 1 comma object 2, or let's put them in what do they call them, square brackets. So we have the square bracket object 1, and then after that we would have a comma, and then after that we would have object 2. Then we end it with square bracket and then a new line, semicolon. Great. So we can then come down here and say that after the construction of pair1, we want to say pair1 dot print, and let's see what this is going to return. So we run this and we have 2, 4 over there. So we can go ahead and replace this with float, and then we pass in float point as well, dot 8. We run this. Great. Then we would have the last, okay, we would have string, and then we are passing a string over here as well. So we run this. Now we have hello world over there. What if we pass in vector objects? What happens? So we have our class vector, and then we are passing in, this is going to be vect1 and then vect2. Great. Then after that, we want to be printing those objects. So let's run this, and we have an error. It says that no match for that operator over there. Right, so in the first place, when the first instance, when we were adding the vectors using the functional template, it told us that there was no match for the plus operator, for the operator plus, and in this case it's telling us that there is no match for this operator. So that means we have to overload it again, this one as well. But then overloading this operator is out of the scope of this tutorial at this time, because we have to include advanced concepts which we have not yet done. So we would not be overloading the operator in this video. We will be doing it later on, right?